This video is about geometric sequences, and as we've touched on in our overview of exponential functions, geometric sequences are the same idea as an exponential function, but we use different letters and a different exponent because we start with the first term instead of the y-intercept. So just a quick highlight of the basic exponential function. My highlighter's not working. The basic exponential function starts with a beginning value. The geometric sequence starts with the beginning value. So those actually use the same letter. In a geometric sequence, we indicate that it's the value of the first term by putting the subscript 1 on it. Next, we look at the rate. So in a basic exponential function, we use b to represent the rate. I don't know why it just did that. So let me find where I am again. That gives me a good opportunity to remind you, or tell you maybe for the first time, that I'm also saving these whiteboards. So if you want to just look at the whiteboard without the video component of it, they are linked in a folder that you can access from the first page of the Google Slides. All right, so again, b is the factor by which we're multiplying a to create that exponential growth. In the case of a geometric sequence, we refer to that as r, and we call it the common ratio. But it's basically the same thing. We just use a different letter to represent it. And then the biggest difference is that we raise it to the n-1 instead of just x, because we're starting at the first term instead of starting at 0. So if n were to equal 1, so if we're looking at the first term, then n-1 equals 0, and r to the 0 power would just be 1. So I would be multiplying my beginning value by 1. So again, it's because we're starting at the first term instead of at the y-intercept. So if I were to graph a geometric sequence, which I don't actually usually do, but if I were to, I wouldn't include the y-intercept. I would just start at x equals 1 because that's the first term. So let's look at an example of this. Say, for example, I have a sequence that is this, and I start to look at it and I say, okay, I can tell that I'm multiplying times 4 each time, and it actually must be -4 because 3 times -4 gives me a negative, and then times -4 again gives me positive, and -4 again gives me that negative. So if I were to ask to write a rule for the sequence and use it to find the 8th term, my first step would be to find the common ratio. So in this case, we've already talked about that my common ratio is going to be x equals -4. I'm sorry, not x equals. This is times -4. And then I'm going to write the rule. I'm going to start with my first term, which is 3. I'm going to then multiply times my rate, which in this case is -4. I'm sorry, not. I keep saying that this is rate. It actually stands for common ratio. I think you could use them interchangeably, although technically rate really is more of a percentage. So it's better to be accurate about the vocabulary, which is common ratio. So that's what I'm multiplying by each time. And again, I use the n-1 as my exponent. And then if I want to use it to find the 8th term, I substitute n equals 8. So I'm finding a sub 8, the 8th term, the value of the 8th term. I've got my beginning value, multiplying it by my common ratio, raising it to the 7th power. So therefore, a sub 8 would equal -49,152. And just a reminder, because I know that the biggest difficulty that students have had with geometric sequences is when do you use that? When do you use n-1 instead of just x? So maybe to be very direct about that, we only use the geometric sequence rule, which is the n-1. when we see the word sequence, or we have a list of terms, or have a table of terms. So if I had a table like this and said that I would actually probably usually, I'm going to erase this X and I'm going to erase that Y, because I would usually say N, which is the number of terms, and then the value of each term. So if you have a table like this, and it's a listing of terms, but in a table format, and N starts at 1, then you're going to use a geometric sequence. The rest of the time, you really would just use the basic exponential function. So there has to be some indication that you want to use that geometric sequence before you would use the n-1. All right, I think that's it on exponential functions. Shoot me an email if you have any questions.